Hello. Today we're moving on to sine and cosine. The lesson earlier, the lesson before this one, is the tangent ratio. So there are two more trigonometric functions. They are called sine and cosine. And so our goal for today is to learn about what those are and use them to solve problems. So one thing is on your calculator, let's review where those buttons are. So we have, there's the tangent, T-A-N, and then sine is abbreviated S-I-N, cosine, C-O-S. So when you're talking about these three, we don't refer to them as sin, cos, and tan. Make sure you're saying sine, cosine, and tangent, just so that you can continue to learn them better. All right, so let me review the lesson before. Grab those papers. The tangent ratio is the ratio of from the angle you're doing the tangent ratio of. It's the length of the opposite leg over the length of the adjacent leg. And so I think I talked about writing it often as like opposite over adjacent, or sometimes it'll be O over A. And so you're going across your angle here. Now these sine, cosine, tangent ratios are always applying to one of the acute angles, never the right angle, always either acute angle here, okay? So let's look at sine and cosine. So starting off with sine. Now again, first of all, this only applies in right triangles. Okay, so let ABC be a right triangle with acute angle A. So we're going to talk about A here. And I'm going to use a pencil here because I want to mark on it and then erase it when we look at cosine. All right, the sine of angle A and cosine of angle A are written as follows. All right, so the sine of angle A, okay, so I'm going to put this theta. Remember we talked about this. Greek letter theta is often used to just refer to an angle. Theta, I don't know the degree measure here. So from angle A here, the sine is described as the length of the leg that's opposite angle A. So I'm going to go like this, O, and then divided by the length of the hypotenuse. So here's your hypotenuse. So oftentimes I'll define that as H. So I've got O over H, and I'm going to add in here. I'm going to write over here to the sine, or to the side. So the sine of theta, whatever angle, I'm going to put opposite O over hypotenuse H. Okay, so the cosine then is the length of the leg adjacent. So here is the angle we're talking about. Across the way is the opposite leg. I'm going to put A for adjacent is the leg basically right next to the angle or touching the angle, divided by the length of hypotenuse. So cosine is going to be the adjacent leg divided by the hypotenuse. So cosine of theta, of A, of any angle, is the adjacent over the hypotenuse. All right. Now we have a couple other functions, or trigonometric ratios, I should say. I just want to briefly mention them. We're not going to do a whole lot with them, but we have a cosecant, described or defined CSC, and a secant, SEC. And so the cosecant is just the reciprocal of the sine. All right. So if you take this example over here, the sine of theta is 4/5. So here's my theta. So my 4 is opposite. My 5 is my hypotenuse. So I'm going to go ahead and mark my 3 as adjacent because it's right next to the angle I'm talking about. So if the sine is the opposite 4 over hypotenuse 5, the cosecant is just the reciprocal of 5/4. All right. So that is the relationship between cosecant and sine. The secant is the reciprocal of cosine. So the cosine is the adjacent over the hypotenuse. So from theta, 3 is adjacent to it. 5 is still the hypotenuse, so it's 3/5. The secant is just the reciprocal. So we won't do much with secant and cosecant. You will encounter those more in pre-calc and calculus. But I just want to mention they just have this relationship with sine, so you'll get into those more. All right, so how are we going to remember this? So there is an acronym that I'd like you to write down, and the acronym is pronounced SOHCAHTOA. So I want you to start with capital S and then lowercase OH, and then capital C, lowercase ah, and then a capital T, and then lowercase oa. SOHCAHTOA. So say that a couple times because it's something that you're going to say mentally a lot when you work these. SOHCAHTOA. So here's what I want you to see. SOH. S stands for sine. The O and the H stand for opposite, hypotenuse, and then A is adjacent. So if we go back to sine, sine is equal to the opposite over the hypotenuse. The way it's written in the acronym, sine is equal to opposite over hypotenuse. So I'm going to write that down here. The sine, and I'm just going to use my theta again, is equal to opposite over hypotenuse, SOH. So it comes in the order that it appears in your equation. CAH. Cosine is our adjacent over hypotenuse. So the cosine of any angle, I'll just use theta, is equal to A over H. And then if you go back to tangent from yesterday, or from the prior lesson, tangent is equal to the opposite leg over adjacent leg, and look at your acronym, TOA. Okay, so over here I've got the tangent of theta, any angle, is equal to O over A, opposite over adjacent. SOHCAHTOA. So I'm going to encourage you to write this at the top of your paper anytime you're working with sine, cosine, or tangent. All right, well, let's look at this first example. We're going to start by just writing ratios. Find the sine of x and the sine of y, and then the cosecant of x and y. I'm going to skip this for now, okay? I just wanted you to have a general, just an introduction or an awareness of the connection between cosecant and secant. So we're going to find the sine of x and y, write each answer as a fraction. So I'm going to use pencil here because my perspective between opposite and adjacent changes when I change my angle. So if I'm finding the sine of x, I'm pretending like I'm right here. So the 20 is opposite, the 48 is adjacent, hypotenuse is always going to be 52. It's that side opposite the right angle. Okay, so if I'm going to do the sine of x, I'm thinking to myself, SOHCAHTOA, sine is opposite over hypotenuse. So from x, I label 20 as my opposite, 52 is my hypotenuse. Okay? And so we can either leave it like that, we could reduce it down if we wanted. I'll go ahead and just leave it like that because right now I'm just doing, I want you to see the opposite over hypotenuse. Okay, sine of y. All right, so if now I'm standing at y, my opposite side is now 48. So my perspective will change on opposite. So I'm going to put O on 48. 20 is now adjacent. Hypotenuse will never change. So the sine of y is opposite over hypotenuse. So my new opposite is 48. Hypotenuse is 52. Okay, and again, we could reduce those down, but I'll just leave them here for now so you can see how they match the triangle. Okay, well, let's move on and look at cosine on the next example. All right, I'm going to write my acronym here at the top, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. All right, find the cosine of P, the cosine of Q, and then the secant of P and Q. We're going to skip secant. And then we're going to write each answer as a fraction. All right, so I want to think cosine. Cosine is the adjacent over the hypotenuse. So starting with angle P, my opposite leg is 65. My adjacent leg is 72. My hypotenuse is 97. So the cosine of P, I need adjacent over hypotenuse, 72 over 97. Okay, cosine of Q. All right, if I'm standing at Q, now my opposite and adjacent are going to switch. Adjacent, hypotenuse is good. So cosine is adjacent over hypotenuse, so from Q, it's 65 over 97. All right. So what we're going to do with the cosine and sine is we're going to set up equations and solve for missing sides. So what we'll have is we'll be given one of the acute angles and then one side length, and then we're going to use the SOHCAHTOA ratio to set that up. Okay, let's look at number 3. Use a trigonometric ratio, sine, cosine, or tangent, to find the value of x in the diagram. We're going to round to the nearest tenth. So I want to remind you why we are using these functions. So if we're trying to find the value of x on this scenario, I can't do Pythagorean theorem. I must have 2 side lengths in order to do Pythagorean theorem, and so we need another method if we don't have enough information. So when I look at this diagram here, I'm going to use 29. So I'm going to label the opposite, adjacent, hypotenuse from 29. So the opposite leg is over here, the adjacent leg is 18, and of course hypotenuse is x. So I look at that and say, I don't have information on O, so I'm not going to use that. So I have the adjacent side, I have the hypotenuse. Which part of SOHCAHTOA should I use? Should I use sine? Should I use cosine? Or should I use tangent? So if I have the A and the H, I have the information attached to cosine. So I'm going to use my cosine ratio. Okay? So remember, on this very first one, here's what I'm going to have. I'm going to do the cosine of theta, and theta is my angle, equals the adjacent over the hypotenuse. So I'm going to do the cosine of 29 degrees, and that is equal to 18 over x. Now remember, cosine of 29 is simply a decimal, and so I want to remind you, make sure your calculator's on degrees. If you have a graphing calculator, you're going to have to go into the mode, or I think it's the mode, I need to look at mine, and find the setting and make sure it's on degrees. Now once you change it to degrees, it should stay unless you do a reset on your calculator. But if you've got questions on that, let me know. I can help you determine that. Okay, so I'm going to view this as a proportion. So I have a number divided by 1 equals a number divided by x. So let's cross multiply here. So I'm going to do x times the cosine of 29. 18 times 1 equals 18. So this is just x times a number. Okay, I want you to wait to the very end to type into your calculator. So I'm going to divide both sides by the number. So I'm going to divide both sides by the cosine of 29, because then these two are canceling out to 1. And so now I can use my calculator. 18 divided by cosine of 29. Now I can close parenthesis if I want, but I'm not typing anything after it, so it won't matter if I don't. So I'm going to round to the nearest tenth. So it looks like it's about 20.6. So x, I'll go ahead and use the approximation sign. What did I say? 20.6. Okay. You can check this for reasonableness. My hypotenuse should be the longest side in every triangle. And so I should get a bigger number than 18. If I don't get a bigger number than 18, either I solved it wrong or maybe I'm using the wrong trigonometric function. Okay, I want you to try letter B. Go ahead and pause the video and then try to set up and solve for letter B. Okay, I have information on the opposite and the hypotenuse. O and H are attached to sine, so I'm going to do a sine equation. So I'm going to do the sine of the degree, sine of the acute angle equals the opposite leg over the hypotenuse. Okay, so there's my setup. I like to turn it into a proportion and then cross multiply. So I'm going to have x times 1 is x. Sine of 42 times 52. So it doesn't matter how you write that. I like to write the number in front and then the sign second, only because I don't want the 52 and 42 to get confused. So I am now just multiplying 52 times sine of 42. Now, if I want to type it in a different way, if I type in the sine of 42 first, make sure you close that parenthesis, okay? So I should then multiply by 52. I should get this value, 34.8. So x is approximately 34.8. So if I don't close that parenthesis, if I do sine of 42 and then I put times 52, my calculator thinks I want to take the sine of this number, and I get 0.4 as my answer. All right, so you want to make sure that you're paying attention to what your calculator is doing. It's going to always open that parenthesis. And again, I check for reasonableness. I say, all right, 52 is the longest side. I better get something smaller than 52. All right, I'm gonna end this video, and then I'm gonna come back and talk about angle of elevation, and then we just have one more example I'm gonna have us look at.